we have two inputs, R1 and R2, and two outputs, C1 and C2. So we need to get four transfer functions, which are C1 over R1, C1 of S over R2 of S, C2 of S over R1 of S, and C2 of S over R2 of S. So let's start with finding the first transfer function C1 of S over R1 of S using the superposition method. This means we focus only on the path from R1 to C1 while temporarily removing R2 and C2. An important point to note: when a block connects to a summing junction, as shown here, its sign matters. So here G2 is originally enters the summing point with a negative sign. Then once R2 is removed, G2 should be considered as negative G2, not positive G2, as shown here. So we neglected R2 and C2 and we got the negative sign to G2. So let's start arranging the block diagram to start block diagram reduction. Okay, for arranging, first we have G1 is proportional to the output C1. Then we're having a feedback loop consisting of G2, negative G2, don't forget the negative sign, in series with G4 and G3. Then negative G2, which is in series with G3 and G4, feeds back into this summing point located before G1. Okay, here is the final block diagram after arrangement. This is what the block diagram looks. Now let's start with reducing this block diagram. We have negative G2, G4, and G3 are in series, so they could be reduced by multiplying them together. This creates a direct feedback loop with the transfer function G1. Okay, as a result, the reduced block diagram will give a transfer function as G1 over 1 minus G3 times G4 times G2. And this is the final transfer function we have